Hello everyone. In this session we are going to discuss about finite automata and regular expression. First, finite automata. We'll see finite automata. Finite automata is the simplest machine to recognize patterns. The finite automata or finite state machine, it is also called as finite state machine, is an abstract machine which have 5 elements or 5 tuples. It has set of states and rules for moving from one state to the another state, but that rules depends upon the applied input symbol. Introduction to finite automata. Basically, it is an abstract model of the digital computer. This diagram shows an essential feature of the general automata in which we have a set of inputs and set of states and set of outputs. The finite automata is an abstract model of a digital computer which has the following components, that is input, output, states of automata, state relation, output relation. The mathematical representation of the finite automata is, a finite automata is a 5 tuple. It is a 5 tuple automata. In this, those are Q, alphabet, Q0, F and transition, where Q is the non-empty finite set of state, and this alphabet is a non-empty finite set of symbols. Q0 belongs to Q, is an initial state or start state. F is the accepting state or final state. The transition function, that is Q into sigma tends to Q, that is the state number of states, the set of states into symbols is leads to some states, that is a transition function. The transition diagram, a transition diagram or a state diagram is a directed graph which can be constructed as follows. There is a node for each state in the Q which is represented by the circle. There is a directed edge from a node Q to node P labeled A if the transition from Q, A is equals to P. In the start state, there is an arrow with no source. Accepting states or final state are indicating by a double circle. Some notations that are used in the transition diagrams are this, the state is represented by a circle and the start state is represented either with the arrow mark or without arrow mark, and the final state is represented by the double circle or a star with preceding the state. The transition table. The transition table is basically a tabular representation of the transition function. It takes 2 arguments and returns a state. The transition table is represented by following things: the columns corresponding to input symbol, the rows corresponding to states, entries corresponding to the next state. The start state is denoted by an arrow with no source. The accept state is denoted by a star. So this is how the transition table is represented. Columns, in the columns we have input symbols, and in the rows we have the states, and in the entries corresponding to the next state, the start state is denoted by an arrow with no source, and the final state is represented by denoted by a star. For example, consider this example. In this is one of the finite automata. How can we write the transition table for this finite automata? In these rows we have set of states. In the column we have input symbols, and inside this, in which state it is going to, it is there, and the arrow mark represents the start state, the star represents the final state. In the above table, in the previous slide table, the first column indicates all the current state. Under column 0, 1, the next states are shown. The first row of the transition can be read as, when the current state is Q0 and input 0, the next state will be Q1. And the input symbol 1, the next state will be Q2. Like the same for the second row, third row, and all the rows. And this is about finite automata. Next is regular expression. The language accepted by the finite automata can be easily described by simple expressions called regular expressions. It is the most effective way to represent any language. The languages accepted by some regular expression are referred as regular languages. A regular expression can also be described as a sequence of pattern that described as a string defines a string. The regular expressions are used to match character combination in the string. String searching algorithm used this pattern to find the operation on the string. For instance, in regular expression x star, for example, x stars means 0 or more occurrence of x. That means x star means it can generate a single x, double x, triple x and 4x, etc. Any number of x. In a regular expression, x plus means one or more occurrence of the x. It can also generate same thing, x, 2x, 3x, 4x, like that. That is an instance. Operations on regular language. The various operations on the regular languages are union operation. Union operation is nothing but if L and M are the two regular languages, then their union L union M is also a union. For example, L union M is equals to S. For example, S is in both L or S is in M. The intersection operation is nothing but if L and M are two regular languages, then their intersection is also an intersection. That is, L intersection M is equals to ST, where S is in L and T is in M. Next operation is clean closure operation. If L is in regular language, then its clean closure L1 star will also be in the regular language. For example, L star is equals to 0 or more occurrence of the language L. Example, we'll see one example for the regular expression. Write the regular expression for the language accepting all the combinations of A's over the set A. The solution for this is all combinations of A's means A may be 0, A may be single, A may be double and so on. A may be triple, 4A's, so on. If A is appearing 0 times, then it means it is a null string. That is, we accept the set of epsilon. Epsilon means A is appearing 0 times. Single A means A is appearing 1 time. Double A means A is appearing twice. Triple A means A is appearing thrice. So on up to N. So we give a regular expression for this as R is equals to A star. A star means it can have any number of combinations of A's. That is clean closure of A. This is about the regular expression. Next, conversion of the regular expression to finite automata. How can we convert the regular expression to finite automata? To convert the regular expression to finite automata, we are going to use the method called subset method. This method is used to obtain finite automata from the given regular expression. This method is given below. Step 1. Design a transition diagram for given regular expression. Design a transition diagram for given regular expression using the NFA with epsilon modes. First we have to write a transition diagram for the regular expression for given regular expression using NFA with epsilon modes. And second step is convert this epsilon NFA to NFA without epsilon. The third step is after converting to NFA without epsilon, we have to convert NFA to equivalent DFA. How to convert all those things that we have studied in the previous sessions. Example, Design a finite automata from given regular expression 10 1 0 plus 0 plus 1 1 into 0 star 1. The solution, we will construct the transition diagram. The solution, how to solve this? The first we will construct the transition diagram for the given regular expression. How to write a transition diagram? First Q0 is the start state, Q of is the final state. We have to take the regular expression. Second step is the regular expression is divided. We have to convert that into NFA, that is 10 plus. We have to separate those two. The third step is again 1 and 0 is separated. We have to separate all the expressions separately in the step 3 and also in the step 4. In the step 5 we have separated all the symbols equally with the number of states. Now we have got NFA without epsilon. Now we will convert it into required DFA. For that we will first write a transition diagram for the NFA. That is, the transition diagram is like that. Transition from Q0 to input symbol 0 is Q3. The transition from Q0 to input symbol 1 is Q1, Q2. Transition from Q1 to 0 is QF. Q1 to 1 is epsilon, that is null. Q2 to 0 is null. Q2 to 1 is Q3. Q3 to 0 is Q3. Q3 to 1 is QF. QF to 0 is null and QF to 1 is null. We have written the transition diagram. By using the transition diagram, we can write the equivalent DFA. We can write the equivalent DFA from the transition table. This is about this session. In this session, we discussed what is a finite automata and what is the mathematical representation of the finite automata, transition diagram, transition table, and the example. And next, what is a regular expression, operations on the regular expression, and how to convert a regular expression to the finite automata, and how to convert, that is converting to NFA without epsilon, and NFA to DFA. This is about this session. Thank you.